Alright, welcome to my third day of solving the daily Leetcode problem. So, today's Leetcode problem is a hard question. And the title is minimum initial energy to finish the text. So we are given the text where a text of index. Technically that means each array in the text will include the two index. One is actual and the second one is minimum. So the actual is the actual amount of energy that we need to spend to finish the index text, and the minimum is the minimum amount of energy we require to begin the text. So let's consider like we are just one robot. So consider us as a robot in this day is a normal because there's so many robots taking over our job. So let me zoom in a little bit. Oops, this is so huge. Alright, cool. So we are here. Alright, cool. So consider us as a tiny robot in here. Let's call robot. So as a robot, I need to do something. Let's say I have a battery of 10%. But if the one text I need to do will cost like 8 energy, but technically the minimum amount that we need to spend is around 10% because we need to consider like going to the place and do the job. So that is the minimum and actual difference. So according to, let's stick with the previous example. So for instance, the text is first 0 index of 10 and the minimum index of 12. So our current energy is 11. We cannot start the text because if our current energy is 13, we can start the test, and then we would finish the test with the energy remaining of 3. That means we actually need the 10 amount of energy to finish that job. So what we need is we have to return the minimum initial amount of energy that we will finish all the tasks. So by thinking of this problem, what I was thinking is, okay, how about we combine all the minimum amount plus greater than one of these minimum. So the actual is 1, 2, and 4. That's technically 7. But we can have the energy of 8. So if we have energy of 8, we can start it. Yeah, I think the example is missing the one case in here. Let's say if we have the energy of 12, we don't know we can start or not. But the example 1 answered our question. If we have the energy of 8, we can finish up all these tasks and remain with the 1 energy. Alright, let's move on to the example 2. So we are given the minimum is here. 1, 2, 10, 10, 8. 10 plus 10 is 20. 20 plus 8 is 8, 28. And that would be 30, and we need the 31. So we need minimum of 31 to start the text, but we may need to consider how much effort we need at the end of the minimum. So let's consider we have like 32 initial energy, and then we spend on the first test, that's minimum is 1. So we can consider this is done. How can I highlight this? All right. So we can consider this is done. Oh gosh. All right, cool. This is done, and we move to the second one. 2. So we're gonna deduct the 2 from 32, 31. That's 29. And next we move to the 29. Deduct the 10. This is done, and this is also done, and then we left with the 8. So what we can consider is if we left with the 8 in here, we need at least energy of more than 1. That's why we consider like +1 to the order initial. I think I can consider just by sorting the input first, so we have a better understanding. Let's consider a sorted text. Let's sort with how much energy we actually need instead of minimum and actual. So that would be make us easier to calculate. Let's consider like first iteration of minimum minus actual of 0 compared to the should be the less greater than to the. Okay, I think I need the one calibration here. Okay, and then we need to think about the second index. If I see second index, that's the first index of minimum minus 1 of. Right, let's just return the -1 in here. I just want to prove about what I'm doing here. Let's run it up. So if we try to sort this thing, what we are actually doing is not sorting by index of 0 or not index by 1. So what I want to do is 4 minus 2 is 2, 1 minus 2 is 1, and 4 minus 8 is 4. So if we see by this problem, let's go back to here. Alright, that's a gradient by SQL. We can easily move it out. So 2 minus 1 is 1, 4 minus 2 is 2, and this is 4. What we got is 4, 2, 1. So that means we are sorting by actual energy that we need to spend. The reason why I'm doing in here is what I'm going to do next is I'm gonna keep track of energy that we have left and the actual answer we need to return. Let's start with the text in our sorted text. What we're going to do is let's decipher the array into our usable value like actual of text 0 and minimum will be text 1, which is given here. So after we get the actual and minimum, what I want to do is I will check if our energy, that means we are trying to calculate how much energy we need, it's less than the minimum. I just want to calculate, do we really need that energy? I'm gonna calculate the need will be the minimum minus actual, our energy. So okay, that's a typo. So after we got the actual need of the energy, what we can do is we can add it to our answer with the need. The same for the energy afterward. So the reason why I'm adding the energy and answer both with the same value of the need is I still need how much energy we actually need to keep spend on the next minor text that we are going to see, because our sorted text is sorted via the not a sequential, it's a reverse sequential. So at the end, after all we done with the energy, I'm gonna remove the actual from our energy. At the end, we can simply return the answer. So let's try to run it out. It solve our problem or not. All right. Okay, let's try to submit. If I'm not wrong, we have to take the Leetcode notation with the actual of this sorted, because we are using the sorted API by the Swift. That will be the O of n log n, if I'm not wrong, and then the memory will be just O of n, since we don't use any extra memory in here. All right, that's pretty much for it, and let's see you in the next one. Bye.